Okay, good evening everyone. Today we will start covering a new topic. It's very important. Before we start, as usual, we go over the topic that we discussed last time. Before the last time, it was last week actually. We don't have any class in Tuesday. So Tuesday was, university was closed. And we covered the generic and interface, how to use the generic. We said that the generic type is we parameterize, we create a class using a parameterized type. So whenever we need to change the type, we just remove the generic type and put the required type. And also we cover the interface. We're going to come back again to the interface in detail later on. Today we will discuss very important topics about aggregation and compositions. Actually, it's not a brand new topic. We discussed the topics on the previous lectures, and you know about it. But today we will give a terminology. We introduce this terminology, aggregation and compositions, and we drill down to explain the difference between aggregation and compositions, and we will define some terminology that we're going to carry on. We take it with us for the rest of the semester. So what is aggregation and compositions? If you go to the Moodle and there is a note, visit chapter number 4 for more details, to read more about aggregation and compositions, and the note will provide you with some useful examples to understand the topic of aggregation and compositions. I try to make the slide more comprehensive, so all the material that you need is inside the slides. Okay? But in case of you need more information, you can visit the note. Aggregation and compositions, before we discuss this terminology and clarify what this terminology means, we established what we call a relation between the classes. In any application for the Java, you have more than one class. So the relation between the classes is simply some features or some fields inside some class depend on the other class. So that's where we incorporate a class inside each other in some way or another. That's what we call as a relation between the classes. And there's two types of relation between the classes on Java: has a or is a. When we say has a relation, implies the class has some fields that are made up of other classes. So you have has two classes, they have has a relation. That means one class has some fields or some attributes that are made actually from other class. When you define your class and you use ArrayList, really you are using another class inside your class. So you have a has-a relations. Another type of a relation is a, implies that the class is a derivative of another class that's derive the same feature or extend the features or extend the behavior. Is a relation is actually an inheritance relations. We're going to come across over this relation when we cover the inheritance. Today we will focus on the relation of has-a relations. That means some fields in your class is made up by other classes. Compositions and aggregation both under the umbrella of what we call is association relationship represent a general binary relationship that describes the activity between two classes. Here is an example. We have a student take course. That's a relation. So if you have a students as a class and you have courses as a class, so the relation between the class of a students and the course class is takes. So the student take class. But the faculty members teach a course. So the relation between the course and the faculty member or the teachers is different, is teaching the course. This is an example of association relations. How we implement this relation? We implement it by defining fields that build or made up from other classes. Here we have a class of a student on the left side, whereas we have a private array of courses. So we store inside this private field a list of courses that the students already take. Now, inside the courses, we have maintained two directions of the relations. The direction of the students, that the students take this course. So I know if I go to the course, I know the list of the students who register in this course. And also I know the list of the teachers who can teach this course. Now, how I can implement the relation from the faculty class, I can include a private array of named courses where I store the courses that the professor teach this course. So this, what we call is association relation. You have three classes in your applications: students, course, and a faculty member, and this is how we implement the relation between these classes. You can see we maintain array list, student list, course list, and we have also course list inside the faculty. But the name of the array list is the same, but it has different meaning in each one of these classes. If you don't need to know the list of the courses that the students already take or the faculty that can teach, you can just simply ignore the course list field. In that case, you broke the relationship. There's no relations between the class of a student and the class of courses, or between the class of courses and the faculty. So if you don't want to maintain the relation, you get rid of the field. But if you need to maintain the relation, you have to put the field which is called the course list. That is what we mean by the field is course list. So if you don't need to maintain the relation, we get rid of this field. Now, there is another concept about the association relations. It's very important to understand the multiplicity of these association relations. There is a relation one-to-one. We say that each student must carry exactly one student ID. This is what in multiplicity. You see here there is a 1 on this side and there is a 1 on the other side, and the direction from the students to the ID card. So each student in this case should carries only one ID. That is what we call by multiplicity of the association relations. But there is one-to-many also association relation. We say that a rectangle list can contain many rectangles. So if we have a rectangle list, this is a rectangle list, and we have one-to-many relation, one and a star on the other side. So if we have a rectangle list, contains many rectangles. That is one-to-many. Example of multiplicity relation. This is an example. We say that a student can take up 5 courses. A student has to be enrolled in at least one course. Up to 200 students can enroll in a course. And a class should have at least 10 students. This is an example given to us. Maybe you can think about it as one part of the ABI specification that will be given to you in the exam or maybe in the final exam, and ask you to represent this multiplicity relation. So given the information here, we can identify how many classes we need. We need 2 classes, one for a student, one for the courses. The second, we need the relations. The students takes courses, okay? And according to this example, the students can take up to 5 courses, from 1 to 5. You could have 2, 3, 4, but 1 is the least and the most is 5 courses. The course can have 10 to 200 students. This is how we represent the text of the relations that represent the relation between the class of students and the course, using only 2 identity, 2 boxes, which is represent the classes, and the 1 straight line and the relation name written on the line, and in the both side we write the multiplicity of the relation. So if I look, I remove the text and I look at this diagram, I can say the students can take 1 to 5 courses, and the course can contain 10 to 200 students. Now let us look at this one. I would like you to take pencil and paper and try to do it for 1 minute. Okay? This is an example. We have a teacher can teach 1, 2, 3 courses. While we are discussing this, try to come up with a diagram that represent these relations. So the teacher can teach 1, 2, 3 courses. Each course is taught by only one teacher. Students can take between 1 to 5 courses. Course can have 10 to 300 students. So we have teacher and we have courses. Do we need more? We need a student. Okay. Now, what about the teachers and the courses? What's the relation between them? 1 to many. What is we should put on the side of the teacher here? What the number should I put here? What 1 to 3 here? And what about here? So 1 to 3 here and 1 to 3 here. Okay. One. Okay. So the teacher teach 1 course up to 1 to 3. So the course taught by only 1 teachers, and the teacher can teach 1 to 3 courses. We have a students, and we have the relation between the student and the teacher, or between the students and the course. What the relation? What's the line? The relation here based on the text between the student and the teacher, or between the students and the course? Between the students and the course. What the number should be from the course side? 1 to 5 and 10 to 300. Okay. This is how, if I give you this diagram, I implies that you can extract this information. Okay. So you can see here, all the text information is represented on this diagram. So both of them substitute each other. If I give you the text, you can come up with the diagram. If I give you the diagram, you have to come up with the text. We say the teacher teach 1 to 3 courses. Where is it? It's written here. Where the course can have 10 to 300. It's written on the text, this relation. In this slide, do I have relation between the teacher and the student? Where is it? Which point? 1, 2, 3, or 4? No, we are discussing this. So let us leave this to maybe at the end of the class. I don't need to confuse the students. If there is a relation between, your question is saying, I thought that I have some text, I forget about it. So there's no, based on this, there's no relation between the students and the teacher. If you want to do the relation between students and the teacher, you have to come up with that relation, and then you can represent it. Okay? If you have a question about it, after the class. Okay? Let us proceed. Now, more association notations. We have exactly 1. Just to draw a line, 1 to many. If we have 0 and 1 to the side, that is an optional, either 0 or 1. If you see on the side 1 or a star, that means 1 or more. If you see 0, dot, dot, and star, that means 0 or more. So when you are reading the diagram, if you see these notations, you are knowing what is the type of the relations. Now, Here, for example, is an employee and a company. Between the person and the company, there are two classes. And we can see the person employs inside 0 or you have 0 or many employees and works with one or many companies. Association relation can be between the same class. So you can have a person and you have a relation of supervised, that is the person. So the relation can be the supervisor or the manager is the same as the person. So the same class has a relation to itself. Also, this is a very natural example that all of you already experienced, that you have a course relation to other course by prerequisite, okay, course. So you have such kind of relation. You cannot take this course. You have to take all the prerequisite courses. And you have some kind of relation, mutually exclusive courses. You cannot take this course with another course at the same semester. You have to take them semester by semester. Now we come up to the main topic of today, which is aggregation and composition. Given all the previous background information and discussions, we have the term of aggregation and compositions that represent the relation between two objects or two classes inside the Java. Both are terms described as a relation. So aggregation is has a relations, composition is has a relation. So if you have a true or false, aggregation is has a relation. It's not is a. Is a relation between the object is inheritance relations. So all the aggregation and compositions both under the has a relations. Now, we have this kind of relation that university has a collection of department and each department has a collection of professors. Now, more explanation about the compositions and the aggregations. We now try to define them. We try to sense what the definition, what the difference between the aggregation and compositions. We say that the compositions imply the ownership. When we have a composition between the two objects, that means the ownership. If the university disappeared, then all of its department disappeared. There's no point of having an object of department flying without assigning this to a university. So university is a composition of a department. That is the relation. This kind of relation between the object will be clarified for you when you are trying to design an object application inside Java. For example, if you are designing an application for university, so university has department, has a collection of department. So there is no point of carrying an object of department without having an object of university. So if you delete the university, you have to delete all the department inside the university. So we say the department cannot live without university. Aggregation, no, does not imply the ownership. That is the example when you have the department and the professors. Yes, I delete the department, but as a professor, they stand alone as a one object. They can be assigned to different department. Okay? That sometimes in some university, they delete department, they merge departments together, okay? Like electrical and computer engineering, electrical and computer science, if they have separate electrical computer science, separate electrical computer engineering, so they merge it together. So when you delete the department, the professor object stay the same. So we say the relation between the department and the professor is aggregation. There is no ownership between them. They can, you can share the professor object to another object easily without any problem. So when you have the ownership, that means you cannot share it. That's another way to think about it. Aggregation, it's safe to share it because I don't own it. Okay, good. Now, how we can represent it with UML representations. This is the class. We say class is aggregation of a class 2. So the class is aggregation of a class 2. And you can see the relation here. The class 2 is aggregated inside the class. So the name for this one is a class. The name here is class 2. And this represents the aggregation relation. So the class is aggregation of a class 2. So that means inside this class there is one or more of a class 2. There is a collection of class 2. And this relation is aggregation because the diamond here is open, not closed. If you try to look at the composition relation, it's the same thing, except the diamond is black, fallen black. So the class is a composition of class 2. So that means the class is on the class 2. So if you look at in some references, some Java references book, and try to represent the relation between aggregation and composition using the diagram, so the only difference is the diamond open, that means is aggregation, closed, that means compositions. Now, this is a strong relation. We say that each person has only one brain. Okay? You cannot have the brain without the person. That is very strong composition relations and full ownership. Okay? Now, we have weak aggregations. Just to let you understand what the difference between them. We have a car and a passenger inside the car. The relation between the passenger and the car is aggregations. The car can live alone and the passenger can live alone. So the car can have 4 passengers, okay? But they are not own these passengers, okay? That is why we have a partial ownership. For while they are riding the car owns them, but once the car stops, there is no ownership between the car and the passengers, okay? Aggregation, we say part of or part of the whole relations. And between the brackets, I mentioned reference. That means when you have aggregation relations, think about reference. We are sharing the reference. What do you mean by reference? We share the address where the object exists. We're not taking all the object. I just give you the address of the object. Okay? I'm not giving you the object itself. For example, you ask me where is the lecture room. I give you the number of the room. Did I copy the room and give it to you? No. I give you the number of the room. So when you have the number of the room, you can go all the university and find the room number and go to that room. So I give you the address of the object. You can go to the memory, look in the memory, and find the object at that address. I didn't give you the object. I give you the address of the object. Okay? So the component exists, may or not exist, depend on a aggregated. Compositions part belong to only one whole. That's mean by value. Okay? The part of this or the field is part of the objects. The part lives and dies with the objects. Okay? You cannot have, as we mentioned as an example, department and a professor. This is an aggregation. University and the department are compositions. The department, they cannot live. If the university dies, the department will die. I mean, if you destroy it, you have to destroy the department. Examples. You have the person, name, and address. So what's the relation between the name and the person? Is a compositions. But between the address and the person is aggregations. Okay? You can see here, we have a class called name, some fields, some constructors, some methods, and we have a class of person. They have field of a private name and a private address. Now, we have a class of address. This is how we implement the relations. Now, what we mean by compositions, the person cannot share his name. I cannot give you my name and allow you to change my name. Okay? That is my ownership. This is my name. I own my ship. You cannot change my name. Okay? But I can change my address. Okay? Now, this is an example again with aggregation for the name and the date of birth. You can see here that we have 2 fields inside the person class. Is a string of name and the date. Date is an object. String is an object. But string is a mutable object. It's easily can be shared and we safe to be shared because no one can change the string. But the date is an object. Someone can change it. Okay? But both are private. That means they are not accessible by the client. We have the constructors, and look here. We have the constructor and we provide the constructor with 2 arguments, name and the date of birth. So we send 2 objects to the constructor. The constructor, what is that? This dot name equal name. That means he just assigned the references. So where is the birthday objects live in the memory at address 600, just assign this birthday at address 600. So just sharing the addresses. But look at the get method. Get the birthday, it will retain what? The value of the date or the reference of the date. This dot birthday, we retain the value or the reference. Here, in the public date, get birthday, this will retain reference or value. We retain the reference. We retain where is the birthday live in the memory. If this object at address 500 will retain 500. We're not retaining the object to the client. Now, example of using aggregations. Note that no copy of the name and birthday is done. We just simply assign the name and birthday. We're not copying them. We just assign them. So if the name is at address 500, we just say this name go to address 500. If the date birthday is at date at address 700, go to the address 700. I didn't create a new object. Just I shared them. That is the example of aggregations. The name and birthday are shared with the client. So the client can change them. That is the dangerous of aggregation. I shared this with the client. The person class shared this with the client. Both client and the person, in instance, have the same reference for the name and the date. Look here. There's a string, the name, and there is a new date. This we create a new object. Now the person, P, is a new person and have S and D. So the P here and the client, this is the part of the client program where he defines a string S and date D and as a new object, okay, and give them to the constructor of the person. P as an object and the client, they have the same reference. To understand this based on the memory hierarchy, let us look at this segment of the memory. We say that we have S as a string at address 250. D is a date object, live at address 350. And P is a person object, live at address 450. So look at the name at address 250, date at address 350, and both the name is pointing to the string object and the date object will be pointing to the date object. So the person, the client, this is the client part, this is the person part, both are sharing the same objects. Look at this memory diagram. So the client object in the top is sharing the string location with the person at the bottom. The person object and the client have the reference to the same string. While here, we have the person object and the client, they have the same reference for the date. So they don't have the actual object. They have only the reference where the object is live in the memory. That is the example of the aggregations. Now, if the client decide to change the year and the month and the date, so if the client do this, the person will see it because both are seeing the same object. Both have the same address. Client can change it by using D. He didn't use P dot something. He used D. D is the reference where the date is live in the memory. The client have that address. So the client can use that address to change the date, and the person will see it. When I print P.get birthday, I will have November 3, 1995. So the client decided to change the date, and the person see these changes. If this is what is you need inside your application, you have to implement then the aggregation relations. Okay? So because the date instance is shared between the client and the person, and this is exactly what we said we are writing here, so whenever you go back to the slides, you know exactly what happened. So the client can modify the date using D, and the person can see these modifications. So the person with P can modify, and the client can see the modification using D, because the same locations we can access either using D or using P, which is the person reference. So the string There's no problem with a string, as we mentioned earlier, because a string is a mutable object. No one can change it. So I can share it safely between the two. So the string, it seems, is the best for aggregation, or if you want to do the aggregation, you don't need to copy the object. Okay, you just need to share the reference where the object lives in the memory. So make your object immutable objects. Okay, so a mutable object can be shared freely without worrying about their status. No one can change the status of the name because they are mutable objects. Once they are created, they are fixed. Here is an example. We say that the UML class diagram for the aggregations, we have the date, number of the date object each person has, and the number of name each person has, and we have the open diamond to indicate the relation is aggregation relation. So whenever we need to implement the relation, this is a hint, whenever you decide to implement the relation between two classes, avoid such kind of relation, one-to-one relation. So I know that the person has a name and some person information about the address and email and the date of birth. So it's good to create one class where all these objects is a member of it. So rather than creating two separate classes, one for the person and another one for the personal info, and the relation between them is one-to-one. So why we not creating only one class called person, and inside this class we define all the field or all the attribute that is related to the person. So we try to avoid unnecessary association relation that is one-to-one. That is all about aggregations. It's about sharing the reference where the object lives in the memory. You're not owning the object. You just give the address, and anyone can change the status of the object, given that the object is not mutable. But if the object is immutable, you can share it safely because no one can change the status, as we saw in the string. Any question? Okay. So the composition is relation about ownership. Let us take this example, and we stay with this example for the next couple of slides. We have object of type X. So we have a class name X capital that has a composed of object of type Y capital. So you have two classes, X capital, Y capital. We have X capitals have an object of type Y capital. So that means it's owning this object. Okay? So that means X has Y object and X owns Y objects. No one should see Y, should hide it inside it. If one asks for Y, he will create a new copy of the status and ship it back to the client who asked for Y. So in the other word, the X object has exclusive access to the its Y, okay, object. Simply, you can imagine you and your cell phone. What's the kind of relation between you and your cell phone? Okay, is aggregation or composition? Is that what I mean? Is a composition, is ownership. You own your cell phone. You give it to someone. Your relation between you and your username and password for the email, or between you and your ECS account, is a composition. You own this account. You're not sharing it with someone and give him the password. So this is the compositions. Okay, this is a compositions. But if you go to the general labs, you sit in the lab to do lab 1 or lab 2. The same machine, the relation between you and the machine that you sit in the lab, what is the type of the relation? Sharing. So it's an aggregation. You have access to it. When you finish, someone come back and use it. So this is the kind of aggregation relation. So keep that in mind while we are discussing the composition, because the composition is a very strong ownership between the objects. So this means that X only cannot share a reference with Y. No one can know where is Y live in the memory. No one should know where is Y live in the memory. You create Y, you own it, and you hide it. No one should access Y. Constructor will create a new copy of y if you pass y as an argument. Accessor will retain a new reference for y. Mutator will store a reference to a new y. If you have to modify y, will create a new copy of y and store it. A new y object will call defensive copy. That's why we have always in all these constructors, accessor, modulator, all of them, we have a new y object. So whenever we need to get or set or construct, we have to create a new y object. We call it a defensive copy. The default constructor is defined when it must be create a suitable copy of y. This is an example. You have x as a default constructor, this dot y, this dot y as a field, new y. So we create a new copy of y. This is a defensive copy. A composition of other constructors like copy constructors. We provide y object. Inside we create a new y. Okay, we're not using y. We create a new y. Always we have inside the composition relation new y. We receive y, but we're not relying on this y. We create our own object, copy of it, and we store it. Here is just to make sure there's some application where you have to create a copy and make sure that this copy is valid. Okay, this copy is valid. Now, why it's deep copy is required in case of composition relation. If we are using copy constructors, public x, and we provide y as a parameters here, then we use this dot y equal y. What this equal, what is the behavior of this equal? Simply go to the y. Where is y live in the memory at address 500? But this dot y equal 500. So y object that is in the parameters at address 500 and this dot y both are pointing to the same copy, which is not a composition then. This is an aggregation. We do not do this in the compositions. So if someone told you that the relation between x and y object are compositions, you should not do this inside the parameter constructor. You have to use a new y. You have to create a new defensive copy of y. So this is called what is a terminology, is a privacy leak. So whenever we have sharing the reference between the client, because y as a parameter is coming from the client side, and this dot y is from the object, that means the object and the client have the same reference, we say that this is a privacy leak. Yes? We're not discussing compositions and aggregation relation with the primitive types. We discuss aggregation and composition with an object type. Okay? There is no, because every time you are working with a primitive, you work with the actual value. Okay? And you pass by value. Okay? So it's totally different, the relations. The primitive always by value, always. So you don't need to do anything. The only we discuss the aggregation and compositions because we discuss the relation between objects. Okay, object they have a status. A primitive they don't have a status. They have a value. Okay, they have if you have a double, what's the double value? If you have int, what's the value of int? There's no what's the status, what's the attributes, or what's the field of int type. No, int is a primitive type. It has a value only. But we discuss aggregation and we drill deep on the aggregation, the ownership or not owning the object for relation between classes, relation between objects. And we discuss the aggregation, and now we are discussing the compositions and what we should do with the composition and what we should not do with the compositions. So the compositions means the ownership. So you have two objects, x and y. X owns y. You should not do this because in this case, client and the object have the same copy. and this what we call a privacy leak for the composition relation. Now, if you have a copy constructor and you pass another x, you take other dot get y, you retain y, and you create a new y. You create a new copy of y. Y is an object. If it's a primitive, you don't need to do this because you are just moving the value of the primitive. Okay? And the value is stored in the memory. So this is the defensive copy. If you have a copy constructor, you should not do this because in this case, other object and this object, they have the same address for y. So both have access to the y, and this is a privacy leak. We cannot allow this. Okay? Now, for get method, if you want to get method inside the composition, you should not say retain this dot y. You have to retain a new object. You have to create an object. That means get y inside the composition is actually a factory method. It will create an object and retain it back. So here we have this dot y, and we put it inside this y. So we create a new object of y and return it to the client. The client will not have access to y inside x. You will not allow to modify it. So in case of copy, we need do copy because if you're doing this, we should not do this inside the compositions. This may be suitable for aggregation, but is not suitable for a composition. This is a privacy leak. We retain this dot y. That means the client will have access to the y object inside x. This is a privacy leak. So now I show you what you should do, what you should not do in case of the compositions, because in the composition is a strong ownership between the objects. So what's the price we pay for the composition? Is defensive copy. That means extra work, extra computation resources, extra memory space that we need to do this composition relation, to implement this composition relation. Whenever we need to access some object y, we have to create an object y. Creation an object y is time consuming maybe, or maybe it needs a lot of amount of memory. Privacy leak is very important, and this is what we mentioned here. This is not a primitive or a mutable. So whenever you expose a reference to an object, this is a privacy leak. So you have an object, you have the field, the relation between two objects, one object as a field in the other class. Okay? If you allow the client to access this field based on the reference, this is a privacy leak. Normally we are using the private to make the access within the client. So the within the class. So private fields, the client cannot access them directly. You need to provide get method or set method to change these private fields. So you have to take care of that whenever you create, implement a composition relations, and you have a private field. So you need to implement a get method. You have to create a new copy of it. So that's what we mentioned here. We have a class and we have a private y of object. So now all the following example is an example of privacy leak. It's bad practice if you need to implement the compositions. So doing this is not a composition. So this is not, these are example. You should not do this with the compositions. I give you y, you should not say this dot y. You should say what? New y. This is not good. You should not retain the reference. This dot y. This is not good. If I give you a copy constructors for x, you should create a new other of y. So you should not assign other dot y to this dot y. So now other x and this x have the same access to the y. In terms of the set, you should not do this. This dot y equal to y. You should always create a new y. So all of these is a privacy leak. Whenever you try to implement a composition, you should avoid this. This is wrong practice. You should avoid this. The consequence of privacy leak, you give a control to the status of the object to the client. So the client can change the status of the object and make it inconsistent. So let's say a credit card and you have the expiry date, and the relation between the credit card and the expiry date is a composition relations. So no one should access the actual expiry date. If we expose the expiry date to the client, that means the client can change the expiry date, and in this case we might put the expiry date before the issue date, okay, which is make it invalid. So this kind of relation here between the credit card and the expiry date is a compositions, and whenever the client is asking for the expiry date, I should create a new object, okay, copy the expiry date and return it back to the user, should not user have access to the expiry date. Okay? Any question? Okay. So whenever you have a privacy leak, it's impossible to guarantee the class invariant. For example, you have a student class and you have the GPA. The relation between the students and the GPA is exclusive. So the students own the GPA. Each student owns his GPA. If I give the client access to the GPA, so the client can change the GPA and put a negative value, make the class inconsistent, and that's break the class invariant, because always the GPA should be greater than 0. So whenever we have access to the field, we broke the composition relations. No more we own the objects. And remember that with the composition relation, if the object is died, all the subset of objects that are composed with this object should die with it. But if we give access to the client, that means the price of a privacy leak, the object will die, but the other object is live in the memory. Okay. Now we will discuss the concept of aggregation and the composition. The concept that the relation between two classes, two objects, composition and relation is finished. But now we will look on that relations for a very important topics is a collection as a field. Always we work with the classes where we have to use ArrayList, set, HashMap, setMap, okay? All of these is a collections, okay? And we use these as a field inside our class. What is the impact after we discuss the composition and aggregation relation on these fields? Before we start, I will remind you with these slides, and we already discussed this slide. What do we mean by alias? In the Java, alias simply the reference to the existing objects. You have the object is created in the memory, you give another name to the object. So you define in your application an object and you give it another name. So you access the object with two different names. This is an example. We have a list. We create a new array list. So we create an object inside the memory of a new array list. And what is the name for that? A list. How we can access this object? Using a list. Now I decide to access this object with plist. So I define a list of a string, plist equal a list. This is called aliasing. So I have one object is created, so one new, and I have a list and plist accessing the same object. So this is aliasing. Keep it in your mind. Now, a shallow copy. A shallow copy, that means you have a collections where the fields of a new object are alias to the field of the copy objects. What do you mean by that? This is an example. You have array list, a list is created, and inside it you define a new strings. Hello student. These are two strings. Okay, you add them to our a list. Now you go, you define a new object of plist. So you see, inside the memory actually you have two array lists because you are using two new array lists. One for a list, the other one for p list. Now you go through the loop of a list and you add the strings from a list inside p list. You didn't create a new string. You just simply, you have two array lists and both have the same access to the same objects. So this is what we call a shallow copy. Okay? So a plist is a shallow copy of a list. This is example what happened. You create a list with some set of strings, and you create plist. So you can see here, a list is an object inside the memory. Plist is an object inside memory. But what is inside a list is 4 objects. These 4 objects, you can access them either a list.get0, you're going to get the first element. plist.get0 will get the same element. Both you can change the object by using the same plist or a list. So that's a shallow copy, which is the example of aggregation. Yes? Because aggregation is sharing. You share where's the reference of the object. So the shallow copy is actually an example of aggregation. I'm not owning these names. I'm sharing these elements. Yes, I understand. I understand. String is immutable. But if someone go here and create this, let's say a list. If someone write this statement, a list dot add to the element of 0 and change the name of 0, B can see it or not? Here is, we are talking about string. String is immutable, you are right, and no one can change it. But take the string and put any object. Okay, take a string and put any object. Both a list and p list, they say the same objects. Okay. See the difference here? What's the difference between this one and the previous one? In this one, we are doing a deep copy. So even the string, it's a mutable object, that's true. We take the string and we create a new string. So now we have the string that's live on different memory. Okay? I encourage all of you to take these 2 subroutines, 2 for loops, and put them inside the Java and run them and see really what we have created, a shallow copy or a deep copy, and how the effect that I can change the element inside a list or p list. And also take the AC example with a string and practice on them. Take this example and change it with any other object. Okay? No. You see here, 2 totally separated. Totally separated. A list, I can change a list, element of 0, and I can change p list, element of 0 to 2 different values after I create the copy. But once I create the copy, both should be the same. But after that, in the object, I can change them. But a list has access to their object, and p list has access to its object. So both are different objects. Okay? And you can see here, we are using a new string. So we take the string value that exists on a list, and we create a new string, and we insert it inside p list. And we end up with this diagram, show us that there is no relation between a list and p list. A list is an object of array list live in the memory. It has some items. P list is also another object in the memory and has different items. Okay? Giving that on your mind about the shallow copy, deep copy, and aliasing, let us discuss the composition and the relations when we ever have the field as a collections inside the object. Okay? So, university has a collection of faculties, and each faculty has a collection of schools or departments, and a recipe has a collection of items. That all these kind of objects, they have a collection inside them, yes? So they have a field of collections. Contact list has a collection of contacts, okay? And from the note, you have a student has a collection of the GPA. For each year, you have your own GPA, okay? And a polygon is an example of collection of what? Triangles. So a polygon is an example where it's actually composed of a collection of triangles. We're going to take this example and carry it on the next slide. So you can see here, we have an array list of date. Date is an object, okay? And is not immutable. It's immutable. So the client can change the status once I create it. So here I create 3 dates, D1, D2, D3, and I add them to the list of dates. That's exactly what happened in the memory. I create a client, create date at address 200. At address 200, I will find addresses of 3 objects, D1, D2, D3. So D1, D2, D3, they live at address 500, 600, and 700. The array list will only store the addresses, will not store the objects, okay? Now, test your knowledge, take half minute, and let me know what is the answer of this. Okay, what's the answer for the question? Okay, but okay, I will hold on that. What's the answer for second one? Let us break it down. We create an array list. So we create a new object. That is called PTS, points. And in the second statement, we create a new point. That's P. And that's we use a new. That means we create a new, we reserve a new memory, and we store 0, 0, 0. Now, I take this P and insert it inside the array list. And as I saw you in the previous slide, what I insert inside the array list? The object itself, I insert 0, 0, 0, or I insert the address where the point is left. I insert only the address. So points can access P using the address. Let's assume the P at address 500. So what is inside the points list is address 500. Then I use P. P, I use it to change X. Now X is what? 10, 0, 0. That is the status of the point. But what is X? X is 10. Then I ask to print P. The P will be what? 10, 0, 0. Then I ask the array list to print what's the point at location 0. What should I see? 10, 0, 0. So the point and the point relation between them is aggregation, because both have share the same address. Okay? So the relation between array X and the X is aggregation by default. By default, Java implement the aggregation relation between the array list and the object inside the array list. That's exactly here with an example. We have a student, okay, has a string as an ID. A student has a collection of yearly GPAs, and the student has a collection of a string. We need the collections. Java, most of the Java application, Java classes that you're going to work in this course or maybe later on has collections. If you're going to go to the next course with data structures, most of the time you're going to work with collections. Okay? So a polygon model, we said that is a collection of triangles. So we have a collection and its aggregation. You can see here as the diamond is open, that is aggregation. We have a list of triangle. We have a triangle object. We insert it inside the list of a triangle. We have one-to-many triangle, okay? And we have a polygon model. Only one model has a list of a triangles. Now, how we can implement this one? We look at the diagram. Now, how we can translate this diagram to the Java code? Let us see here. We have the class polygon model, and we have a list of triangle. We create a list, private list triangles. The object that inside this list is a triangle. We use generic here between the triangle brackets, generic. So triangle is an object. Now we have TRI. It's a triangle, abbreviation for triangle. Now inside the inside the default constructor, we have this dot. This dot triangle is equal a new array list of triangle. Okay, we create a default constructors. Okay, now we have public void clear. That is exactly gonna call the array list clear method. This dot triangle dot clear, that will go to the element inside the object of array list and clear them out, remove them from the list. Size will retain the size of the array list. Now, collection as field. So when we are using collection as attribute inside the class X, this is more generic. we need to decide the ownership of two issues. X own or share the collection. X own the collection does not own the objects held inside the collections. Okay? So you have to make sure X owns the collections, X owns the object inside the collections. Okay? All these should come to your mind whenever you are working with the collections and you try to implement a composition and aggregations relations. If X share the collection with other X, then the could be constructor does not need to create a new collection. We just retain the collection. I don't need to create a could be collection because I'm not owning the collections. Okay? So the could be collection simply retain another collection, and that is the aliasing. We define it in the early slides. So look here, a could be constructor receive another polygon model, and simply there is no owning for the collection. So this dot triangle is equal to other dot triangle. So other polygon model and this polygon model both have the same array list. Both have the same array list. They share. So aliasing, no new list is created. Now, even when I retain get triangle, I will retain this dot triangle. I will retain this triangle because I'm not sharing the, I'm sharing the triangle. This is a memory diagram. Focus on this memory diagram. We have P1, P2, we have a triangle, and we have a triangle at address 700. So P1 and P2, they are a polygon model. They are polygon models. And you have a triangle, polygon model at address 700, and at 200 and 500. P1, P2 are polygon model, stored at address 200, at address 500. Inside, because you are sharing the array list, inside 200 objects, you have 700. What is inside 700 is an array list. Inside the second polygon model at address 500, there is an array list. Also, they have the same address, 700. So P1, P2, they are sharing the same array list. And what is inside this array list? We have address 1000 and 1100 where the object of triangle is left. That means we have two objects of triangles and they are shared between the P1 and P2. This is what we call a sharing. So polygon model does not own the array list. Okay? Now, take half minute, test your knowledge on this one. Any suggestions? Okay, I will try to help you. So we have a polygon model that use a could be constructor, and the could be constructor do aliasing. So aliasing, that means sharing. Aliasing means sharing. Okay, so this is an aggregation relation. So we have the first polygon model P1 has 100 triangles inside the array list. Now we create P2 using a could be constructor, and the could be constructor doing aliasing. That means P1 and P2, they have the same array list. They see the same array list. One array list exists on the inside this application, and it's shared between P1 and P2. Then I use B2, B2.clear. In this case, because P1 and P2, they have the same access to the same triangle list, so I will clear out the list. So what I should expect the size if I say P2.size? 0. Then P1.size? 0. That's true because both have the same array list and I clear the array list. I use P2 to clear it. So that is what we call sharing or aggregation relation or aliasing, where two objects, they have access to the same array list. Okay, now this is an example of shallow copy. X owns the collection. Okay, I own the collection, but I don't own the object inside the collections. Okay, that means I have to do what? A shallow copy. And you know what is the example of the shallow copy we discussed early on this slide. A shallow copy means X create a new collection. If I ask you do shallow copy for this object, that means you have to create a new array list, but you don't need to create a new object for each element inside the array list. So here is an example. You have as copy, whereas you create a new array list, and for each object inside the dates, you take the object and you insert it inside as copy. Okay, so here is the shallow copy. I create a new array list, but the element or the object inside the array list, I don't need to create a new object of it. Okay, so another way to create a shallow copy with one command without doing or for loop is relying on the array list constructor. I just provide the dates array list, then as copy will be a new copy of array list but has the same element. This is an example back to polygon model. We need to implement a shallow copy. So as you can see here, inside the copy constructor, I use the other. I use other.triangle. I create a new array list, but all the triangle inside the array list, I don't use new for them. So they are a shallow copy. How the memory is look like compared to the previous one. Here you have P1, P2 at address 200 and 500. Okay. Now, because you are using copy constructor, at address 200, you have a first polygon model P1. You have array list at address 700. You go at 700, you see that you have two triangles, 1000 and 1100. Now, at address 500, you have another polygon model P2. And this P2, we need to create a shallow copy. Look at that triangle list. There is a new triangle list at address 800, not the same one at 700. So I go to the 800, I see that I have two triangles. And these two triangles at address 1000 and 1100. So you can see here, both have two new array lists. One at address 700, the other one at address 200. Two independent array lists, but both have the same element, the same triangle. Here at address 1000, 1100. This is what we call a shallow copy. Now, given that, test your knowledge, take half a minute and test your knowledge here. Any suggestions? Okay. No. Here we have P1 has 100 elements, 100 triangle. I create two array lists because I create what a shallow copy. That means two array lists. The object is still 100 triangles. The P2 is pointing to 100. P1 is pointing to 100. I use P2.clear. I clear P2, but P1 is still the same. So in this result, I will have P2 0, but P1 is 100 because this is a shallow copy. Okay, it's different. The previous example was 0, 0 because I share the list. Here I'm not sharing the list. I have two independent lists. I share the object inside the list. That is aliasing. What about this one? Any suggestions? True. False. Okay. So here we are sharing the same object, but we're not sharing the array list. So we create P2 from the same list of P1. So I T1, T2, this should give me the same object. Would live on the same address. I should see true. Okay. I should see true. Okay. Now is the extreme case, extreme ownership. I own the collection and I own the object of the inside the collection. No one should access the collection or the object inside the collection. That's what we call a deep copy. Deep copy. So here we have a date, date, that means deep copy, and we create a new array list. And look here inside add, we say dcopy.add, and we use a new date to create a new date from the date. So I have two new lists, and I have two new objects for each one. So I create a deep copy of the list and a deep copy for each object inside the list. Here is the polygon example. We have created a new array list, okay, to do a deep copy, and we look through the elements, and for each triangle we create a new triangle using a copy constructor of triangle objects. So we create a copy of the array list and a copy of triangle. This is example of the memory list. You have P1, P2 at address 500, 200, and 500, and we have two array lists at address 700 and 800. Look at address 700. You have object triangle at 1000, 1100, and at 800 you have a new list. We have address 20,000, 2000 at 2100. The memory is continuing. The next page you will have two triangle at address 2000, 2100. So you create a new array list and you create a new object inside the array list. That is what we call a deep copy. Now, test your knowledge here for this one. What do you think the answer? Yes? Do you agree? Yes? Okay. What about this one? False, true. Yes, because we create a now get 0 for P1, gonna retain address 1000. Get 0 for P2 will address 2000. Now when I say address 1000 is equal to 2000, that's not true, that's mean false. But if the identity or the status of this triangle is the same as this triangle, yes, because we are using copy constructor. So we're gonna have false, true. Good. We close for today. Finished. So we're gonna see you next Tuesday.